Hello everyone, welcome back. In today's video, we are going to uncover the magic behind the fascinating bitwise operation n and n-1. This is simple but powerful technique used in many algorithms and can help you understand bit manipulation better. So let's get started. First, let's see what is n-1 with respect to n. So for n-1, we subtract 1 from n, right? And that results in flipping of all the bits right of the rightmost set bit from 0 to 1 and also flipping of this rightmost set bit from 1 to 0. Let's take some examples to understand this better. For example, when n is equal to 4, we see that only bit set here is 1. So we will flip all the zeros right of it to 1 and this 1 to 0. Let's also see it by subtraction. And when we subtract 1 from it, we will get 3 or 0, 1, 1 in the binary representation. We flipped 1 to 0 because that's the rightmost bit and the only set bit in 4. So we will flip it and we will flip all the bits right of it from 0 to 1. Similarly for 6, when we subtract 1, we will get 5, which is 101 in binary representation. So we start from the least significant bit, that is the rightmost bit. 0 minus 1 is not possible, so it has to borrow from its next bit, that is the bit on the left or the middle bit. And because it's a binary number system, we borrow 2. So 2 minus 1 becomes 1. And because we borrowed 1 bit from the middle bit, now middle bit becomes 0 and the leftmost bit stays 1 only. And that's why we will get 101 in binary representation and the integer value is 5. And note that this was the rightmost set bit. So this was flipped to 0 and all the zeros right to it flipped to 1. Let's look at one more example. For 11, binary representation is 1011. So here the rightmost bit is this one. And when we subtract, we will get 1010. There is no zeros on the right of this one. So this is the only bit which is flipped. And now we have understood what is n-1 with respect to n. Let's now try to understand what will bitwise and between n and n-1 do. N and n-1 results in a value or a number with all the bits from n remaining the same except for the rightmost set bit which becomes 0. So for example, when we do 4 and 3, it will result in 0 because 0 and 1 is 0, 0 and 1 again is 0 and 1 and 0 is 0. Because AND operator returns 1 only when all the inputs are 1, otherwise it will return 0. And here in 4, there was only 1 bit set. And when we do n and n-1, that got flipped. So this will result in 0. Similarly, for 6 and 5, we will get 0 and 1 is 0, 1 and 0 is again 0, and 1 and 1 is 1. So only the rightmost set bit has flipped, that is, it has become 0. And now let's look at the next example. Let's do 11 and 10. So here 1 and 0 will become 0, 1 and 1 is 1, and 0 and 0 is 0 again, and 1 and 1 is 1 again. So here again we see only the rightmost set bit has become 0. All the remaining bits on the left of it are same. So to summarize, when we do n-1, the rightmost 1 bit in n becomes 0 and all the bits to the right of this bit in n becomes 1. And when we do the bitwise AND operation between n and n-1, that clears the rightmost 1 bit in n. Now let's look at the applications of this operation. Bryan-Kernighan's algorithm utilizes n and n-1 operation to count the number of set bits or 1 bits in a binary number efficiently. That is also called Hamming weight. It continues to perform this operation until the number becomes 0. And if an integer has k set bits, this operation will run k times. And Bryan-Kernighan's algorithm basically counts how many operations it takes to get that number to 0. Isn't that smart? The time complexity to find number of set bits here will be O of k, where k is number of set bits in n. Another application of this operation will be to calculate Hamming distance, that is number of differing bits between two integers. So first we just perform the XOR operation on two integers and then again count number of set bits using Bryan-Kernighan's algorithm. And third useful technique is to check power of 2. So if you notice, all the integers which are actually power of 2 like 8, 16 or any other integer, they have only one set bit. So when we do n and n-1, the rightmost set bit or the only set bit gets flipped, that is it becomes 0. And because of that, n and n-1 becomes 0 in the first operation itself. And we come to know if number is power of 2 or not just in O1 time. I hope you find this video useful. Don't forget to give it a thumbs up, share it with your friends, and subscribe to the channel for more coding tutorials and insights. Thanks for watching. See you next time.